Okay, so remember that functions are just a way of looking at equations, right? So this can be a function, right? That is a function. It gets one input and gets one output. We can write it as a function by using function notation, something like that. And then we can evaluate it by plugging in a value, like that. So you remember all that from our last lesson. We've looked at linear functions, and those are functions that give us, like this one, a straight line. Today we're going to talk about non-linear functions as well as linear functions. Remember that functions can be represented by our equation, like this one. They can be represented by a table. Can be represented as a mapping diagram. You'll remember where we had some values over here and some values over here, and we mapped them together. And they can also be represented on a graph. These are some different functions represented in graph form. So here are some linear functions. These are the ones we're used to, horizontal line. And these are some typical non-linear functions. This one is a quadratic. We're going to do one of those today. And this is an absolute value function. So non-linear functions are non-linear because they're non-linear functions. They don't make lines. So let's take a look at a few examples. Here we have a function right down here at the bottom. Y equals 2x plus 1. Let's see what kind of function this is when we put it on a graph. So we'll just start plugging in values. For example, we'll plug in a 0 for our value from up there. That's 2 times 0 plus 1. So when we solve that, we get 2 times 0 is 0, plus 1 is 1. So with an input value of 0, we get an output value of y. We can try again. We'll put a 1 value in there. Try 1 there, plus 1. 2 times 1 is 2, plus 1 is 3. So with a domain value of 1, we get a range value of 3. And we can try others. Let's do negatives. Let's do a negative 1. 2 times negative 1 plus 1. That's going to give us negative 2 plus 1, which is a negative 1. Plus 1 is negative 5. So here are our different values. Now, if we want to see what the function looks like, we just have to graph it. So we'll take our x values. We start at 0, and we have 0, 1. Roughly right there. We'll try to do that again. 0, 1, and then 1, 3. And then 2, 5. And then negative 1, negative 1. So here we go to negative 1, and we come down, negative 1 there. Negative 2, negative 3. Negative 3, negative 5. Now, if we look, we can see that this is going to be a line. We can see even that we can calculate our slope here. If you look between this point and this one, we can go up 2, so our slope is going to be 2, and then our rise, rather, is going to be 2, and our run is going to be 1. So that gives us a slope of 2 over 1, which is exactly what we have here. That's our slope. This is a linear function. We can draw our line, and that's our line. We know this is a linear function. We know it's a function because if we were to do a vertical line test, if we were to take a line and draw it through at any point on here, then we would get it only touching at one point. So here's a straight line. It's only going to touch at one point. It doesn't matter where we move that straight line. We can move it back and forth. It's always going to touch in exactly one space. So we have is it a function? Yes, it is a function. Is it linear? Yes, it is. Certainly it's a linear function. Let's take a look at another one. Here is another equation. Y is equal to x squared plus 1. So let's try to plug in some values, right, to fill out our table. 0 squared plus 1. So 0 squared plus 1 is going to give us 1. And then we'll do a value of 1. So 1 squared plus 1 is going to be equal to 2. Now I'm going to go ahead and populate the rest of these a little quicker, and you can fill those out as you go. Negative 1 squared is 1, right? Negative 1 squared times negative 1 squared is positive 1, plus 1 is 2. So now let's go ahead and graph those on our grid. So we've got 0. At x of 0, we have a positive 1. At x of 1, we have positive 2. X of 2, we have positive 5. Well, that's different. And then negative 1, we have, positive 2. That's interesting. And negative 2, we have 5. That's familiar. And then negative 3, we have 10. So we'll put that up here. By the way, if I was to do positive 3, 3 squared is 9 plus 1 is, that's also going to give us a 10. So positive 3 is going to be 10 as well. And we can see that this is a very special kind of a graph called a quadratic. It makes a parabola. So it's not a V, it's actually arching up like that on both sides. Looks like an upside down, one of the arches for McDonald's there. So that's a parabola. Is this a function? Well, if we were to draw a straight line anywhere along the way here, we would see that it only passes through at one point. No matter where we move that line on our graph, it's always going to pass through exactly one point. So that is, in fact, a function. And is it linear? No, it is not linear. Again, that is a quadratic or a parabola. All right, one last equation for us to take a look at as an example. Here is another one. Y is equal to the absolute value of x. Remember, the absolute value is the distance from 0. So if we plug in a 1, or rather a 0, the absolute value of 0 is 0. So that's 0 there. And the absolute value of 1 is 1. And the absolute value of 2 is 2. What about the absolute value of a negative number? If we take the absolute value of negative 1, what do we get? Well, we get 1. So that's also going to be 1. Let's go ahead and graph those. What we'll do is start at 0, 0 here. That'll move us up to 1, 1, and 2, 2. It looks like we have a linear graph, doesn't it? Let's see what happens. At negative 1, we go up to 1 again. Negative 2, we go up to 2. Negative 3, up to 3. So it looks like what we have actually is two different lines, both of them starting there at the origin and extending outwards. And that is what an absolute value function does. It creates this V, and sometimes it'll start at the origin and sometimes it'll start somewhere else. This is a non-linear function because it doesn't continue in a straight line. It's not as liney as other functions.